is Mrs. Tripoletti again. I'm here with Unit 1, Lesson 2. By the end of today, you should be able to write equivalent expressions using the product of Power's law and the quotients of Power's law. This is our goal for today. Remember, you should have already checked your homework, your independent practice from last night with the answer key. If you have any questions from previous lessons or this lesson, remember to check in with us on Google Meet. Okay, so today we're going to be talking about two different laws that we're going to learn about. And one is the product of Power's law. And let's think about what the word product means. In math, product means to multiply. And the word quotient, the quotient of Power's law is going to be our second law, and that means to divide. Okay, so we're going to work with these two laws today. But first, let's take a step back and answer these questions. So please do so on your paper. Okay, here are the answers. You should be following along in your packet, and you should have written these answers down. Up here, just wanted expanded form. So remember, you do not actually have to calculate anything here. Just write it in expanded form. And then here it wanted exponential form. So remember, you just needed an exponent, and again, you did not have to calculate anything. Okay, also just to note, it is extremely important that you're putting these parentheses here. If you're not, this is considered an incorrect answer. So this will not be accepted. Fractional bases need to be wrapped in parentheses. Okay, if you're confused by that, please watch yesterday's video. Okay, let's take a look at our next page. Let's get into our first law. Let's explore. How can we rewrite this expression 3 to the 5th power times 3 to the 7th power so that it is written as one term with a base of 3? So 3 to the 5th times 3 to the 7th equals 3 to the what power? What number goes here to make this expression equivalent to this expression? Well, let's think about it for a second. Let's take this and write it in expanded form, and this and write it in expanded form, so we can clearly see what that looks like. Okay, so this would be 5 threes, this would be 7 threes. Remember, at any point you can pause this video if you need to jot down your notes and I'm talking a little bit too fast. That's the cool thing about these videos. Okay, so you could always stop, pause, write things down, and then unpause. Okay, so if this is our first expression, this is our second expression, and we're multiplying them, what number do you think will replace that question mark? Well, if you said 3 to the 8th power, you're incorrect. I don't know why that says 3 to the 8th power. Cut. Well, if you said 3 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 power, you'd be correct. Think about it. That's how many 3's there are. So 3 to the 12th power would be our final answer. Now, and of course it would be 12 would be the answer because it's just asking for the exponent. But what if we wanted to do 3 to the 50th power times 3 to the 70th power? Are you really going to write out 53's and 73's and count them all up? No. So what rule could we make that would make this more efficient? Think about it. What can we do with that 5 and that 7? Well, if we took 5 and added 7, you would get 3 to the 12th power. Okay, so our product of Power's law is going to say that you're going to take anything that has the same base being multiplied, you keep the base, and you add the exponents. Okay, so this is using variables to represent the rule, but you can also say it in words when bases are the same, meaning this is a 3 and that is also a 3. So you can't do this if this is a 3 and that's a 5. Okay, they need to be the same base. You keep the base and you add the exponents. Okay, keep the base and you add the exponents. So let's try a few examples. Okay, example 1. 5 to the 2nd times 5 to the 4th. Well, the bases are the same, so my rule applies. 5 is going to remain our base, and then we're going to add our exponents. 5 remains our base, and we get 6. Now this intermediate step here is really useful when we're just starting to learn, but eventually I'm going to stop writing that step, and you can as well. So just going right from here to here is acceptable. You can just write 5 to the 6th power. Okay, if you're asked to show your work though, this would be considered your work. Where did the 6 come from? Well, you added 2 and 4 together. Okay, example 2. Why don't you take a second and try that one on your own? Okay, so we have -2/3 raised to the 4 plus 5 power. Base is the same. Keep the base, add the exponents. Okay, make sure you have your parentheses. If you don't, then this would be marked incorrect because fractional bases need to have parentheses. And then that leaves us with -2/3 raised to the 9th power. All right, let's take a look at the next page. It says, let's exercise those brains, complete the following problems. So take the next few minutes to fill out this page, and then I will show you the answers. Okay, let's take a look. Here are the answers to exercises 1 through 7. You're just adding your exponents. Make sure for exercise 2 that you have parentheses around the base because you have a negative base. Make sure that for exercise 7, if you don't see one, put 1. So if there is no exponent, that means that there's just one b. So you have to put a 1 there. Okay, so it's 51 b's and 1 b gives you 52 total b's. Okay, if you need to pause this in order to check your work, please do so. And here are the last 2 examples. Again, you must have parentheses around this base because it is negative. And then over here, it wants to know what this base has to be, or what this exponent has to be in order for this exponent to be a 14. So if this is a 9, 9 plus what would give us 14? 9 plus what would give us 14? And I used some algebra there to get that answer, but the numbers are so simple, you don't have to do that. Okay, next page. Please, again, make sure you're following along. Now that we know something about multiplication, we actually know a little bit about how to divide numbers in exponential notation too. How can we rewrite 3 to the 7th over 3 to the 5th so that it is written as one term with a base of 3? Okay, so similar to last problem, only now we're dividing. Well, let's rewrite this in expanded form and rewrite this in expanded form. Okay, 7 3s and 5 3s. Okay, you know in math that you could just go through and cross off these numbers right here because 3 divided by 3 is 1, right? So that would just give us 1, that would give us 1, that would give us 1. We can just cross off all those. What are you left with? You're left with 3 to the 2nd power. Okay, so 3 to the 2nd power would be our final answer. So let's think about it for a second. What did we do with our exponents when our bases were the same? Well, we had our base stayed the same, and then in order to get a 2, we subtracted our exponents. So that gave us a 3 to the 2nd power. Okay, so our general rule would be when you are dividing and bases are the same, you subtract your exponents. Okay, so this is similar to our last rule. Okay, when bases are the same, keep your base and subtract the exponents. Okay, so when bases are the same, you keep your base and subtract your exponents. Now, this is very, very similar to our other rule, okay, when you're multiplying, okay? And a way to remember these rules is an acronym called MADS. So MADS, what that would stand for is, 1 second, let me get my pen going here. MADS is when you're multiplying. Oh, give me 1 second. The computer is glitching a little bit. There we go. There we got it. When you're multiplying, oops, you add your exponent. Oops, oh boy. You add your exponents. When you're dividing, you subtract your exponents. Okay, so that's what MAD stands for. When you're multiplying and bases are the same, you add your exponents. When you're dividing and bases are the same, you subtract your exponents. Okay, so let's take a look at these examples, example 3 and example 4. First one, the base is the same. We have 3/5 and 3/5, so we keep a 3/5. And then we have an 8 and a 6. Since we're dividing, we have to subtract our exponents. That's our work. And our final answer would be 3/5 to the second. And yes, you do need to have parentheses around the fraction. Okay, example 4, 4 to the 5th, 4 to the second. The base is the same. We keep the base, and we subtract our exponents, which gives us 4 to the 3rd power. Okay. Take a second, complete this page, and then we will show the answers. Okay, here are the answers to exercise 9 and 10. Make sure that with the number 10, you have your parentheses around your base. Exercise 11 and 12. Again, make sure with exercise 11, you have the parentheses around your base. A negative base needs to be wrapped in parentheses. With exercise 12, you're going to subtract your exponents to give you a 1. 13 to the 1st power is the same thing as 13, so you can write either one. More commonly, you will just see a 13 written there instead of a 13 to the 1st power. Exercise 13, don't let the variables throw you off. It doesn't change anything. And then exercise 14. Be careful because there's 2 steps involved in exercise 14. Whenever you have a fraction, you should always simplify the numerator and denominator first before you divide. So here we have the same base. So we kept the base and we added our exponents. To get x to the second. Here I just dragged that x along. I added an x to the first just so I could see what the exponent was. And then I have a division problem. So bases are the same, keep the base, subtract the exponents. X to the first or x, both answers are the same. Okay. And here are your notes. Remember, this is your textbook page. You can read through these. It gives you a summary of our 2 rules. So our 2 rules for today were the product of powers law and the quotient of powers law. Remember, when you're multiplying, if bases are the same, you keep the base and add the exponents. When dividing, if bases are the same, you keep the base and subtract the exponents. You can use MADS as an acronym to remember that. Okay, this helps us to compute with numbers way more easily than having to actually calculate everything. Okay, if bases are not the same, you cannot follow these rules, so you would just have to use the order of operations. Okay, we'll talk about this more in the next couple of days. You have your show what you know here. Remember, this is just extra practice if anybody's interested in it. You can bring up questions in Google Meets if you're interested. And then your independent practice. This you should be doing, and then checking the answer key that's posted in the assignment for today. Okay. Thanks guys for listening, and I will be back tomorrow with another lesson. Have a good night. Bye.